All right, creepy screen. So, some scheduling things have come up. So initially, I had planned to be at a conference next week. Given everything that is going on in my world right now, decided not to go. So I had been debating whether or not I wanted to hold class on the 10th, even though I told you initially that we wouldn't. And I was thinking about that because we are behind relative to where I had wanted to be at this point in the semester. Not your fault, mine. I never guessed correctly on how long things are going to take. But then I got an interesting note in the mail last week, which is that I get to have jury duty on November 5th, which is a class day. And I filled out the little juror questionnaire, and I said, I would like to be exempt from this on this day because I have to teach this class, and I'm the only one here who can do it. And I got another note back in the mail yesterday that said, nah, don't care. Show up on the 5th. So we're going to have to lose that day. So I would like to propose that we do have class on next Wednesday on the 10th. If you've already made plans to not be here, fine. I don't keep attendance. I trust that you guys are all motivated adults and that if you're not here, you have good reasons not to be. So it won't offend me if I don't have as many people, but I would like to have one additional in-class FaceTime so that we can stay on track. And so I have added on the 5th here, potentially no class or office hours on this day, depending on whether or not I actually have to go and do this. I've never been selected for jury duty in my life, and of course it happens like 10 minutes before I leave the state, right? So, anyone had jury duty before? Yes, Justin, how was it? Was it just one day and you got to go back to your life? Did they like hold you? It was just one day? Okay, that's what I'm hoping. Otherwise, I'll have to like be really unpleasant and make myself unselectable. That's my backup plan here, right? Game the system just a little bit. You didn't tell them that? If I tell them I'm an academic, does that make me worse or better? Okay, thank you for that helpful tip. Maybe I can be done in the morning and we can still have class in the afternoon. That will be nice. So, given the juggling of the schedule, I have moved quiz 3 that was supposed to be due on Monday to be that Wednesday. So by then we will have tackled enough of Lecture 5 to be able to answer some questions about that. Homework 2 is due this Friday. And I've gotten questions from a few of you that suggest that you're not sure either how to connect to get into this computer room remotely or else where the data are. So let me tackle each of those. So the data for this homework are inside the homework portal. When you log in, you should have available to you homework 2. Do you see the link when you log in? Okay. At the top of the page, download your homework 2 data files here. It's a zip folder that has everything you need. One of the first tasks that you'll have to do after doing some basic reliability analyses is to create a CSV file for analysis in M+. And I will remind you that I gave you some resources on how to do that. On the main course page here, Lisa's M+ guide, this handout has code at the bottom of the first page into the second for SPSS, for SAS, and for Stata on how to make a CSV file. In any program, you should be able to do a save as and ask to make it CSV. The one trick, the thing that is easy to screw up, is that you want the option where there's no variable names at the top of the file. So row 1 should be data, not names. So there should be an option in each of these programs, put names equals no, no var names, etc., to make sure that happens. If you can't figure out how to make the names go away, open the file and delete the first row, and there you go. So M+ will yell at you if the names are in the file. So how do we get to M+ from this room? I've got a few questions about that. So you all should have remote desktop access to this room via your KU ID. When you're off campus, here are the steps to be able to use it. So first off, if you're off campus, you need to use the VPN, which is called KU Anywhere. I have this saved as a program in my start menu. So it's KU Anywhere is the name of it. You can go to ask the Google for KU Anywhere, and you can find it for free and download it. So the address is kuanywhere.ku.edu. Once you pull that up, hit connect, it will ask you for your KU information. So my KU user ID is just my first name. I will put in my KU password. I hit accept. It spins, and then it says established, and it looks like nothing happened. But in your taskbar, you should have a little lock sign on it that shows that you're connected to the network. Next step is to find remote desktop. So I have Windows 10 on this laptop. It shows up as its own program under R. On earlier versions of Windows, it was under, I think, Windows Accessories. You might have to do a search for it on your computer if you don't find it. But in this version of Remote Desktop, you open it up. I'm going to make a new one here. So there's an Add button. I am recording this, by the way. Desktop, connect to a PC. Under PC name, it's the number that you are assigned to. If the number that you're assigned to doesn't work, go ahead and try one of the extra ones down here. But I assigned you each a number. That way you're not trying to log into the same computers as each other. Rather than use one of these numbers, I am going to use my office number. So it is IP address 129 dot this one. Okay. Under user account, this is the tricky part. It's not usually your KUID first. You have to remember to hit home and then a backslash first, because that logs you out of whatever local account that you're logged into. Oh, this account is already set up. I already did this one. And then you would enter your password. So once you do that, this is my account that I already set up when I was practicing. You should get a computer screen in front of you that looks as if you're sitting right here. So this is my office across the hall. This is Huey. Yet again, I've showed him to you before. So he has blown up my Google Photos, by the way. So he and I share an iPad, of course, right? My 3-year-old needs an iPad. And my Google account was loaded into the iPad up until this past weekend, where he figured out how to take pictures. And so I have like a collage of 8,000 shots of the dining room table and the floor and like someone's foot, because he's just walking around like this all weekend. So there's a note. Make sure that your 3-year-old does not have access to your Google Cloud, because he will fill it up with random photos. So does that help clarify how to do this? Okay, has anyone gone through these steps and been unsuccessful in trying to log in? If that happens to you, please send me a screenshot of what your login screen looks like so that I can troubleshoot the information that you're providing, and I can get further help if needed. Again, don't go to KU support because they're not aware of this particular arrangement. Okay, there's that. So other questions? Any questions on homework 2 if you started it? Yes, sir. Sure, let me pull that up. So the formula for omega is towards the end. Find it here. Strain, voodoo. There it is, slide 67. So in this formula, var f is the variance of the factor, which you guys should have as 1, given how I've asked you to identify the model. This term here is the sum of the loadings. So you sum, then square that term. Order of operations matters. That whole thing shows up in the denominator as well, plus the sum of the residual variances. So the numbers in your output are already given as the residual variances. You don't have to square them. And then this is the part here. So inside the parenthesis, would be any error covariance estimate, so that comes from the unstandardized solution. If you had more than one, you would sum them, and then multiply that sum of the error covariances by 2. Is that what you did?
Yeah, but it wasn't working, but I'll try again. I don't know.
Okay. M plus, I believe, squared is star 2 as opposed to caret 2. That might be one thing. Also double check your parentheses. So sometimes for these sorts of formulas, it might be easier to make one new parameter that's like this chunk, and then another new parameter that's this chunk, and then feed them into a third thing. That way you can make sure that your parentheses stay accurate. But if that still doesn't work, please send me what you have, and I will help you troubleshoot. Or you can show it to me in office hours, either way. Okay. Other questions on homework? That means you've gotten pretty far. Good job. All right, due Friday by 11:59 p.m. That way you can have a nice weekend without this hanging over your head. All right, then. So we don't have too much left to do. What I want to do is make sure that you guys feel comfortable going through this process, make sure that I've answered all the questions that you might have, and talk a little bit about sort of how you would apply this in real life via questions that you guys have asked me. So let me, let's see, I'm going to call on Mayumi, because you said you have some questions. So give everyone the background of what you're doing. You're going to be my pet example for today. Yay. No, yes, yay. Free consulting, yay.
Yes, I know.
Yeah, they pay me in everything. So, yeah.
So very quickly, I have this, I have 21 item survey about self-determination. If you're interested in, you can take the survey as well, see your self-determination status. But anyway, so because we include adults, students and adults with disabilities, we thought it's easier to have a scaling.
Mhm.
That you can choose whatever within the line, like you can like finding like this. But anyway, so based on that, the scores, roll scores go up, and then I want to see if like maybe age might impact your self-determination score. Younger people usually have lower self-determination status than older people. But this self-determination has 3 different essential characteristics. And so I'm going to, I have, so one construct has items underneath, and then overall.
Can you give me the title of that article, because I can bring it up and probably show what it looks like.
The impact of personal characteristics on scores on the self-determination inventory. Maybe that one.
Google Scholar.
Yes.
First author, Waymeyer?
Carrie.
Okay, I need more words then. On self-determination and what?
Self-determination inventory.
Nope.
Adolescents with and without information.
Well, I have one from Waymeyer. I might have a factor structure though.
Yeah.
That's what I'm trying to find. That's fine, Carrie. Okay, I'm not going to be able to find it quick enough for it to be useful, but this is a rating scale, right? So it's not a Likert scale. It is a slider bar where basically you mark how far over you think you are and agreeing with the sentence, and where you can go from 0 to 99.
Yeah, so the question is like, I think of more than one way to
Okay, so then I'll draw out the rest of what you were saying here. So you have, in theory, a higher order is a term we haven't talked about yet, but it means sort of the big self-determination factor, which in turn causes responses to 3 facets of that, and it doesn't really matter what they are for our discussion. We'll just call this 1, 2, and 3. That's a terrible 3. Let me try that again. There, that's almost a 3. This is the part where I wish I had a tablet to draw on, but oh well. And there are 6 items on this one, right? 6 items under here, and 9 under this one, right?
Yes.
And then here's where the boxes are for the actual items, right? So you said that your big picture question is stuff that predicts self-determination, right? Age, disability group, etc. Okay. So even though what you really care about is at the top, we got to work our way up to the top to get there. And so that's the process that you're asking about, what comes first. So let me draw more lines here to fill these in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, forgive my drawings, but I'm trying to keep it so that everybody can see it. So each of these factors has 6 items. We'll do a review here. Each item gets what for an estimated parameter? 3 things. Intercept, error variance, loading. What are each of those for? What are they in charge of predicting? Intercepts are supposed to capture what about an item? Means. Residual variances are supposed to help fill in the gap to get to what? Not the mean, the other one. No, the intercept goes with the mean. The residual variance goes with the item's total variance. So that leaves the loading. What are loadings in charge of? They predict covariance. So in each of these factors that has 6 items, how many possible covariances are there? There's a formula, right? 6 times 6 plus 1, so that's 6 times 7 is 42, divided by 2, plus 6 is 27. So there's 27 possible parameters. I take away 6 means, that's down to 21. I take away 6 variances, that's down to 15. So there's 15 covariances that these 6 loadings are supposed to be accounting for. Given that I have 6 items, is this factor number 1 here by itself, is it estimable? Yes, good. What do I have to do to identify my factor? To make the model possible to estimate? I'm sorry? Yeah, so we have enough degrees of freedom because we've got 6. The question is, how do I tell M+ how to estimate the model? I have to set one more decision. Remember Happy Birthday? How do I know where to start singing? Yeah, I got to set the key, got to set the scale. So I have to set the variance of the factor and the mean of the factor. Easiest way to do it for now, what you're going to do in your homework, mean 0, variance 1. So it's estimable in the sense that we have enough information to do this. We have 15 loadings that we're trying to approximate with the 6 covariances. 15 covariances with the 6 loadings, excuse me. Clearly I need some more do before I continue. And we have a scale for the factor, so we're good. So this is step 1 for you, Mayumi. Make sure that that is really one factor for those 6. Repeat for number 2, repeat for number 3. The logic of doing each separately is trying to narrow down the scale of your troubleshooting. If the 6 don't fit under number 1, it'll be a lot easier to troubleshoot that 6 by 6 pattern than to troubleshoot all of them at the same time. So absolute fit then, what are you going to look for when you fit your one-factor model for factor number 1 here? What do you want to see on your output? And this can be directed at anyone who'd like to participate. Heather, you look really unhappy. What's she going to see? You don't know? Like fit indices. Give me some letters. RMSCA, do you want that to be big or little? It's a little one because it's error in it. RMSCA is fit relative to what? Saturated. Saturated, the worst or the best? It's the best around. Nothing's going to keep you down. It's a Karate Kid shout out, by the way. Thank you, Lucas. I appreciate it. He gets my jokes. Yeah, it's good. So yeah, RMSEA, we want that to be, give me a number. What would be a good RMSEA according to classical conventions? 0.05 or less? Do I get a p-value as to whether it is 0.05 or less? I do. I actually get a test of that, and it has a special name. Remember? Close fit. Very good. Yes. So you want to see that. Give me some more letters. What else do you want to see? CFI. Is that a big or a little? That's a big. Is it relative to the best model or the worst model? Worst, which is null, which is no covariances whatsoever. Along with CFI, you'll see TLI. And there's one more that usually shows up. Another set of letters. S. SRMR. Is that a big or a little? That's a little. Yeah, that's how far off each of your predicted correlations is on average. So let's say, just hypothetically, that even though this is a validated scale, your one-factor model for these 6 doesn't fit. Now what? Do you write it up and turn it in? Not this time. Not yet, anyway. What's step 2 if it doesn't fit? If those numbers aren't where we want them to be, what do we do next? Look more Yeah, the report card thing, exactly. Look more locally. So you will get, let me show you an example of what you will get, since I have a 6-item example. Look more locally. Excellent. So this is the idea of local fit. I'm in example 4, page 9. I computed in Excel a leftover correlation matrix. I'm using correlations because their scale is easier to understand than covariances because we know what a scale of a correlation is. So this is literally the difference between what the data say each of these 15 correlations is and what the model says it should be according to the standardized factor loadings. So if I had a discrepancy covariance matrix, that would have been relative to the unstandardized loadings. When I phrase it as correlations, it's relative to the standardized loadings. So what do the loadings say this pattern should be? What is it in the data? And then literally how far off are each of these cells? And so this pattern of off is your guide to what you do next. M+ gives you this pattern in a slightly different form. You're going to look in your very, very voluminous output for something called normalized residuals. It takes each of those offnesses and phrases it as a type of z-score. So you want to look for relatively big values, anything over 2 to 3-ish, indicates serious misfit of that particular element. If it's positive, your items are more related than what the model says they should be. They want to be more together. So in your case, Mayumi. Am I getting your name right, by the way? Okay, good. Still working on that. In your case, these 6 are not all of the same kind, right? There's 2 kinds within the 6. The other article that you showed me, the facets, so to speak? Oh, yeah.
When they broke down to 21 items,
Yeah, it's confusing across articles, but point being, these 3 items are one thing, still under the heading of one, and these 3 are another. Okay, so if they're right, I'm going to put on my crystal ball. I see this should be 2 factors instead, because if you need 2 names, odds are good it ain't one thing. Same thing if you have a name of a factor that has a slash in it. If you couldn't come up with one word, it's not one thing. That's just my own gut formula here. So watch for that, because you may need yet another layer under 1 to capture the 3 and the 3, and the 3 under the 1, and the 1 under the higher order. Can be done. The job of each of these little factors is to predict the relationship among the items. So by saying that I may have 2 factors under this, I'm saying that these items are more related and these items are more related. And the cross sets then is given by this factor up here, the 1. So other than if you guys are in a situation where you don't have an answer key like this, you don't know that it's actually 2 things, and your 6 items don't fit, things that you can do, things that you can look for. So in this example, I made a second factor based on this particular pattern of certain items going together in terms of their residual covariances. So 2, 4, and 6 all wanted to be more together. 2, 4, and 6 had a commonality in their valence, and that's why I did it this way. This doesn't mean that a 2-factor solution is always the best response. What M+ is going to suggest to you is never to add a factor. Ever, ever, never. M+ will only suggest how to repair the model that you currently have. So its version of this is going to be, well, you have a 1-factor model with a shit ton of error covariances. That's what you have. Now, how many of these could I theoretically add before I run out of degrees of freedom? If I have 15 covariances, 6 loadings, what is the difference? 9. Yeah, not a trick. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It gives me 10 that are greater than 6, and I could only have 9 of them because that would fully saturate my model. Now, that would be a pretty terrible idea to add 9 error covariances, because each one of these is an acknowledgement of unexplained multidimensionality. It's no longer the situation forgiveness factor. It would be situation forgiveness and stuff. And stuff is not terribly convincing. So it's far better when you're in a situation of misfit, which most of you will be, to try and come up with any kind of theoretically defendable alternative structure that would make more sense and see how that fit would compare. So you could add maybe 1 error covariance if you could make an argument and someone would buy that argument. But in general, that's not the right approach, and it's like the last case scenario. What if you found out that one of your 6 items had a loading that was non-significant? What would one do in that situation? Do you need it? I think you could omit it. If it's not significant, it's not helping you. Now, Mayumi's case is a little bit different, because I'd say you could omit it with an asterisk behind it, because your ultimate goal is to compare your version of the survey that's adult report with another version that's adolescent report, right? So it is entirely possible that an item that is relevant for adolescents that would have a significant loading is not relevant for adults, and it would not. So I wouldn't drop any items if I were you yet, because of your eventual interest in comparing this to another sample in which they all were relevant at some point. But for those of you who don't have that as a constraint, you can consider dropping items that don't load. You could also consider dropping an item that shows up repeatedly in the list of error covariances. It just seems to not want to play nice with the others. Being careful to make sure that you don't damage your reliability in doing so. But let's say that it works. It works, right? You get nice, happy fit for your 6 items. How do you then describe that? Besides just CFI, RMSEA, fit is good, hooray. What else is the next sentence? Yeah, but you're not at number 2 yet. You got to tell the readers about one more thing, actually 2 more things. Step 3 and step 4 after local fit. Effect size. So effect size versus fit, what's the difference? We just went over fit. Fit is how well your factor model predicts, mimics, I'll say mimics, not predicts, but captures or mimics the covariance pattern.
Isn't it where the shows like 2.1 everywhere, like just because of politics, so we see that relationship above 1.
Yep, that's exactly it. Each of these correlation matrices would result in a very well-fitting single factor model. The job of the factor is to mimic whatever correlation or covariance pattern is there. It doesn't say whether there are any correlations worth mimicking. Effect size is the latter. You could have a perfectly fitting factor model with all non-significant loadings. Can happen. So how do you know that you have correlations worth fitting? Well, step 1, stare at this correlation matrix before you begin your analysis. If they're crappy, game over. If your items are not related, it is not reasonable to ask a factor to then explain those non-relationships. So how do you convince a reader then that your factor actually makes sense in addition to fit, effect size? So what do we talk about then? Standardized loadings. Why standardized and not unstandardized in this case? Yeah, the unstandardized are scale specific. So you have to know what the original scale of the item is and how much variance it had. So even when your items have the same scale, like in this example that we did, where all of the items are on a 7-point scale, their variances differ even within that constraint. So you'd have to know exactly how much variance each item had to begin with before the unstandardized loadings would make sense. The standardized loadings take all of your data, set the item variances to 1, set the factor variance to 1, so the standardized loading is the correlation between the item and the factor. And everybody knows what a correlation is. Even people who didn't take this class, right? Your readers will know what a correlation is. So you would either have a table of loadings, or even if you do have a table, you might put in a sentence that says standardized loadings were all above 0.5, or standardized loadings ranged from 0.3 to 0.8, or something like that. What if reviewer 3 comes back and says, I can't believe you didn't report R square. Everybody reports R square. What do you say to reviewer 3? Dear reviewer 3, we apologize for not being clear. As now added to the table, I heard several people say it, the standardized loading squared is R squared. So you really don't need both. But if someone really needs you to have both to make them happy, you know how to do it. And M+ will give you both in the standardized solution. standardized solution. Here's my factor loadings is the first section under the by here. And then here's my R square, which is just that squared. So take your pick as to whether you want to report R squares as your effect size or R's. I'd say 6 of one, 12 of the other, or something. No, 36 of the other. There we go. Okay, Miami, you've got one more thing now. You're not quite done with factor number 1 yet. One more thing. How do I know that this trait is measured reliably? Omega, yes. So sometimes people don't say omega, they say something like model estimated reliability. It's helpful if you provide either the formula or a citation so people can know exactly what you're referring to. But I will review how to get an omega. So I ended up with 2 factors in my example. Therefore, I have 2 omegas, because omega assumes unidimensionality, so each factor has to be unidimensional. So I'm on page 12 of example 4 to review how you can get M+ to compute reliability for you. At the end of each of these lines of syntax, before the semicolon, I have parentheses in which I have inserted labels. So L1 to L3 refers to the factor loading for situation 2, 4, and 6, respectively. L4 to L6 is for the next set of 3 items. I is for intercept. E is for error. Those are my letters. You can only have 8, but you can call them whatever you'd like. And for completeness, I also labeled the factor variances, the factor mean, and the factor covariance. So then omega is calculated by M+ as a new parameter. So there's a section called model constraint that is a keyword. It does not turn blue for reasons I don't know, even though it's a modeling command like the others. I am defining a new omega p for the positive items and a new omega n, which is a linear combination of estimated model parameters. So I'm not adding any parameters. This does not change the degrees of freedom of my model. I am asking it to do math on parameters that exist already. So then when it sees L1, what it's actually going to do is go up to my model and grab the unstandardized loading for situation 2 and substitute that in everywhere it sees L1. Likewise, for E1, it's going to go up there, find what E1 refers to, realize that it's the error variance for situation 2, and take that error variance estimate and plug it in for E1. So then, in the formula, I have added 1 for the factor variance. This is the sum of the loadings in parentheses squared over all of that plus the sum of the error variances. So note that I have my entire denominator wrapped in parentheses here, as well as each piece. That's really for my own sanity. This is where the error covariances would go. So in this case, you would have an extra line if you had an error covariance. For example, it would be sit2 with sit4. If I named that ecov in here, then I would do something like this. And again, parentheses are just for my own sanity and separating out the sections of the equation. And actually, I need one more thing besides ecov. What did I forget? The 2. Twice. Yes. No, it's the unstandardized solution that you're referring to. You actually get slightly different estimates if you do unstandardized versus standardized. And given that you can't easily label the standardized solution, you would actually have to compute it and then label it. It's easier to do it this way. Okay. All right. So now you're done with number 1. Repeat for number 2. Repeat for number 3. Okay? And then put them all together into one model in which factors 1, 2, and 3 get to be correlated. So it would be F1 with F2, F2 with F3, F1 with F3. And then you can get an estimate of how well that thing fits as a whole. So we haven't talked about higher order factors yet, but let me go ahead and spoil the surprise. Why did I tell her to fit correlations or covariances between the factors rather than fit that SD higher order factor? Do you think the model would fit better if I put the SD factor in it instead? Let's ignore the boxes and focus just on the circles here, the 1, 2, and the 3. How many indicators does that SD higher order factor have? 3. What happens when you only have 3? Estimable but not testable. Meaning that even though the model as a whole will still be over-identified because of everything that's happening down here, this part right here will be just identified, meaning it fits the same whether you just let 1, 2, and 3 be related or you make a higher order factor. It is 6 of one, half dozen of the other. So we're talking about 2 different things here. The bottom circle is the measurement model. How well do the items map onto the factors that you thought they did? How reliably do they measure the factor? Then once you get that in order, the top circle is the structural model. How do the factors relate to each other and to other constructs? So then comes the part where, in theory, you could actually answer your question. If all of this works, you have a higher order factor of self-determination. So we talked a little bit about this in terms of strategy. When would you stick with 1, 2, and 3, and when would you stick with this SD? So we're talking about 2 alternative models. Here's one of them versus another one. And I'm putting a question mark because that's like whatever predictor you care about today. You can have as many as you'd like of those. They can be latent or observed. So here's the alternative model. And these covary, and that one. So I'm turning it on its side to make it a little bit easier to see, but it's the same idea. Okay? So here are 2 equivalent representations, essentially. You can have 3 correlated factors, or the correlations can be captured by loadings of a higher order factor. When you would prefer one versus the other boils down to what do you want to do with this. So if you go with the model on the right, it might be the case that, let's say, what is this going to be today? Age, right? We'll make it the age because that's a short word. Age. There, H. It's hard to write with a mouse. What if age predicts factor 1, but it doesn't predict factor 2? Could that happen? Sure it could. So if that's the case, does this alternative model on the left make any sense? I'm putting this to be age, where it predicts the higher order factor instead? This one path only makes sense to the extent that these 3 paths are the same. Because that's kind of what you're saying. It is technically possible to do something like this, where in addition to age predicting the higher order factor, it predicts each of the lower ones too. But these models can be quick to become not positive definite. Everything can go out of bounds because there's too much overlap in what you're trying to estimate. Technically, it is possible if you have enough information to do it. You can see to what extent age predicts each of these, basically not the factor part that's left over. So you have SD that is factor, and then these become leftover factor variance, and you're seeing if age predicts leftover in addition to predicting common. But to me, that's hella confusing to think about versus something like this one over here, which is relatively straightforward. And you can test whether or not age predicts 1 the same way as it predicts 2 by setting up equality constraints and seeing if the model fits differently. That's an empirical question as to whether these paths, these arrows, have different estimates. Okay. How are we doing? This is structural. This is all about the structure then. It's all about factor stuff at this point. The items are basically irrelevant. That's why we're building this house sort of one layer at a time, right? You got to get your foundation right or the whole thing crumbles. Now, I said in theory you could progress to this stage. However, whenever you're looking at any kind of predictor and whether it is related to your factor, you are assuming that your factor is measured the same way. So we are assuming that self-determination in this case is defined by its items equivalently for people of different ages. It's what's known as measurement equivalence or measurement invariance in the CFA literature. It's known as differential item functioning in the IRT literature. But it's the idea that the measurement part of the model, that all this stuff, come back, down here, all that stuff is equivalent across age. If it's not, then it's really hard to see if age predicts self-determination if self-determination is two different things depending on how old you are. So we're not there yet, but we will get there eventually this semester with measurement invariance. Okay. Questions on any of that? This pathway to parceling. Yes, that's where I was going next. But I was going to see if anyone else wanted to play free consulting and get answers to their homework. No? You're good?
No.
You don't want to play?
No.
No? Okay. I don't have to play. I'm just offering. Some people don't want to talk in front of class, and some people are okay with it. But yeah. And you have a record of our meeting, right? Like, it's our class today. So. Yay. So. Yes, it's sometimes helpful to have the record. So, yes. So that heads into, let me see if I can find the last thing here. So, summarizing all of this stuff, this is where we were. Now, what if reviewer 3 says, well, that's fine that you did all this modeling, but where's your alpha? Where's your alpha? I need an alpha. You're not getting past me. I'm the gatekeeper here. I haven't learned anything since 1960, but I am editor of this journal, and I am going to not publish your paper if you don't give me an alpha. Dear editor, what do you say? Yes, here are your alphas. However, I have retained the omegas in addition for the following reason. We haven't exactly talked about this yet, but I've hinted at it. So what does alpha assume? 3 things. Unidimensionality. Is that a problem in what the editor is asking for? Yes, that's where we're headed. If he wants an alpha for self-determination, you got to tell him no, because that makes no sense. Same thing with an alpha for any kind of total score. Makes no sense. Now that being said, if I find out that you gave the editor an alpha so that you could get your paper published, so that you could graduate, so that you could get a job, I'm not going to yell at you, because I understand that. But you can report the right thing too. So what if he's wanting it for these little factorlets right here, like number 1 here? What if he wants an, excuse me, I'm being a sexist. What if he/she/they wants it for number 1? That's a reasonable thing because we've already figured out that number 1 is unidimensional. So what's number 2 on the list? What you said a minute ago. Tau equivalent, which in this context means equal loadings. Number 3 is no error covariances, which may or may not be true, but omega builds into it unequal loadings and any possible error covariances. So what if you don't have error covariances? Then is it okay to do alpha? The answer is maybe. So this is the last piece here before you'll be ready to do your homework. This is slide 69, testing classical test theory assumptions in CFA. Whether or not the loadings can be made equal and not hurt model fit is a testable hypothesis. You can give said editor or reviewer 3 a p-value to support whether or not you should be able to use alpha or whether you should be able to use omega instead. Alpha is a more specific case of omega in which all the loadings are the same. So in example 4, we get back down to the very end. We're getting close to finishing this finally. And as predicted, we're probably not going to get to the next one, but that's okay. Let me do this one first, and we'll go back and look at pictures. So here, I am testing on page 14 the assumption of tau equivalence for one factor at a time. And I'm doing the negative one first, because why not? So note what I've done here. Rather than saying L4 to L6, I have filled in one word. Neg load, which is my version of negative loading. It's one word. That means that everything on that line before the semicolon gets the same one parameter. So it's not just a label, it's an instruction to constrain. It is saying take whatever the loading would have been for number 1, number 3, and number 5 and make it the same. So then you end up with these results right here, where they are all sitting at 1.254. So I used to have 3 loadings. Now I have 1. How many degrees of freedom have I saved? 2. So it's a nested model comparison. So here's what it was before. 19 parameters, now we're down to 17. You have to do the math yourself for the comparison of the 2. Nope, not that one. Hang on, I need Excel. There we go. There's an example for you in here. Someday. Here is the difference. So for 2 degrees of freedom saved, the model got better or worse when I constrained it. It's significant, so you know it's one of the 2. Worse. I took away parameters. I started with 3 loadings, and now I only have 1. So that savings of 2 degrees of freedom made the model worse by a chi-square of 34. So the answer is no. For this factor, I can't report alpha. I shouldn't anyway. P less than 0.05. So let's do the other one. Positive loadings. Note that I have added in an omega-like calculation, although since I only have one loading, the sum of the loadings is just that one loading times 3. So if equal loadings holds, omega is alpha, so long as it's unidimensional and you have no error covariances. In this case, the comparison saving 2 degrees of freedom is non-significant. So is this not better or not worse than what I had before? Taking parameters away. I started with 3 loadings for the positive factor, now I have 1. Not worse. Not worse means that alpha and omega should be the same, essentially, within estimation error. And the last one, if tau equivalence holds, you have the opportunity, if you want to test for parallel items, which is equal loadings and equal error variances. So on the line that has the error variances for 2, 4, and 6, I've added another constraint to save another 2 degrees of freedom. And this name of reliability is what's known as Spearman-Brown reliability. So it's an even more constrained version of alpha that has equal loadings and equal error variances. And this is the version of reliability. This is the constraint that has to hold to do like the Spearman-Brown prophecy, or the figure out how much better your reliability would be if you had more items thing. This has to hold for that to be valid. And in this case, let's see what happened. Nope. I've never actually seen it hold in real data. So practically speaking, the extent to which these constraints hold, equal loadings and equal error variances, is also a test of to what extent you are allowed to just add these items up instead of going through this trouble. Because you will see that pretty commonly. People will do the factor analyses, figure out that it fits and that everything's okay, and then they'll just add shit up and use the sum scores in their analyses. That's my reaction. No. Because when you add stuff up, you're assuming they're all equally related to the trait and that they have equal error variances. And that is the only situation in which if you output a factor score and you have a sum score, they will be perfectly correlated 1-to-1. That's the only situation in which they're perfectly correlated. Now that being said, even models in which they don't have equal loadings and equal error variances, so long as they're unidimensional, the correlation between the sum scores and the factor scores are going to be around 0.9, 0.95. So it's not all that wrong, provided you've done your due diligence and made sure that your factor is in fact unidimensional, to use a sum score instead. So it's like if you have to because of sample size or whatever. So here is, for example, in the negative items, we didn't have tau equivalence, but even so, if I had just taken the mean of those 3 items and I plotted it against the factor score, that's a correlation of 0.97. It's hard to argue that that's too wrong. The key would have been if I took all 6 and added them together, even though their correlation between factors is only about 0.6. The factor scores themselves, you can ask M+ to create factor scores for you. And these are useful sometimes for descriptive purposes. So the model that we had that we ended up with 2 factors where each item got a different loading and a different error variance, the factor score standard error was around 0.4 for each of my factors. Now what does that mean? Here's what omega was. 74.77 for reliability. Would you call that acceptable? Like ish, right? 0.7, 0.8. So if it's like borderline acceptable, not bad since it's only 3 items per factor, but what kind of information about a person's standing does that actually translate to? Well, let's look at the standard error of the factor score. The variance of our factors scores is supposed to be 1, right? If I wanted to build a confidence window around a score, 2 standard errors on either side, right? So 0.8 standard deviations positive all the way to 0.8 standard deviations negative is the window around a score of 0. So I can only be reasonably certain about someone's factor score within 2 standard deviations approximately. Does that sound very certain to you, very reliable? Nope. I could hit a dartboard with more certainty than that. So yeah, even though my happy little factor model fits very nicely and reliability is borderline acceptable, this is not enough. Unless you want something more, if you're okay with 2 standard deviations as your level of precision. Now the other thing that's going to happen to you is in your output you're going to see characteristics of your factor scores, sample statistics for the estimated factor scores. This covariance matrix right here refers to the factor scores. Our model says the factors are supposed to each have a variance of 1. If I output a predicted factor score for each person, what that actually is a measure of central tendency for their factor score distribution, a mean in this case. And my actual factor scores in the data file that I outputted have a variance of 0.77 instead of 1 for the positive factor, and a variance of 0.825 for the negative factor. They have less variability. They're squished. And that happens any time that you don't have a lot of information. It's called shrunkenness, and it's why you don't want to output factor scores if you don't have to. So here's the factor score distribution for positive and for negative. You can see the same pattern in both. It's supposed to be normal. It's not quite normal because it's up against a wall on the right side. These are the people who answered 7 to all 3 items. I have no idea how high they would actually be. I have to find a way to separate them out. I need more items, or I need something above 7 for them to respond to. More items would be much more preferable. So I show you this because a lot of times when people are trying to get a model that's well-fitting, they end up dropping items. The more items you drop, the more likely this is to happen to you. Questions on that? Okay, so Mayumi, your question then. What about parceling? We're going to talk about this later in the semester, but now is as good a time as any. And I think I can use this picture still, although it's pretty messy. So parceling, actually no, we're going to make a new one. I can't use this. Parceling. So you may have something like this. This is my SD higher order factor. And as we said, there's factor 1, there's factor 2, there's factor 3. And this has actually another layer to it. Doesn't matter what they're called. The idea is that there's another layer of 2 for each of these, and 3 for this one. Okay? And then each of these has 3 items. So the boxes are all the way at the bottom. Parceling refers to the practice of taking some items, but not all of them, and adding them together. So for instance, she showed me a paper in which the lowest level, the 3 for each of the circle, are added together to create one new observed variable instead of 3. Now, what did I just tell you about adding shit together? What are you assuming when you add shit together, whether it's all the shit or just three things? Tau equivalence and parallel items, equal loadings, equal errors. It would be very straightforward to estimate a model in which you did not add anything up. Let me just draw three of the boxes here. That was meant to be a box. And you put constraints on the loadings to make them all equal, and you put constraints on the error variances to make them all equal, and that would be the right way to do a parcel. So if you're in a situation in which you want to do something like this, but you've got like 50 people, you want to estimate as few parameters as possible. One way to do that is to make things share. If you really think that those three items are basically equivalent, you can estimate one loading for them and one error variance. That's two things instead of six. Makes sense, right? Whether it's okay to do that is a nested model comparison, but that's what a parcel is. It's adding things together without actually testing the constraints that you are implying, assuming, when you add them together. Now, why would you do that? Well, the original model, with all of the items intact, there's 21 of them, right? How many degrees of freedom do you have for 21 items? 21 times 22. Yeah, someone's got to help me on this. I can't do that in my head. $462 divided by 2. 231 plus 21. 252 degrees of freedom for the actual model with the 21 items. 252, hang on to that. Better yet, I'll write it down. 252. How many degrees of freedom for the Cheaty model of the parcels? 7 times 8. 56 divided by 2. 28. Doing math in front of you is always bad. Plus 7. It'd be 7 times 8. That's 56 divided by 2. 35. 35. What do you think is easier to do? Get a good fitting model with 35 or a good fitting model with 252? 35. Except it's cheating. So yeah, I'm going to go on record. It's cheating, it's wrong, and I'm not going to support it. That being said, I'm not on your dissertation committee. So you can do whatever makes you graduate. And you can take up this battle later when you are on internship or a postdoc or a faculty member or whatever you want to be when you grow up, right? I'm a pragmatist. But yeah, if you want to do parceling, do it in the model. That's what I would say. Fit the constraints that you are implicitly assuming when you add shit up. Ta-da! Does that answer all your questions? For today, at least? Yeah, I'm the bearer of bad news. So yes, I think we finally hit the end of the handout. It's amazing. It only took like a month and a half. So and yes, here's your write-up. This won't be relevant for assignment 2 yet, but it will for assignment 3, in which you get to do this with your own data. So any last other questions before I close the book on CFA and open the book on IRT and IFA? Alrighty then. I will see you on Wednesday. Office hours start now.